Moving on to B2 from the long test in March 2016. It's a question and analysis, and I focused the question mainly on volumes of revolution and on arc length from this type. So calculate the area region bounded by the x-axis and the lines x equals 1 and x equals e, giving you answer in terms of we show you full working. So we could have, in fact, I think it's a very, very good idea to have an idea of what the function looks like. So I'm just going to do a quick sketch using my calculator to help me, so we know exactly the area what we're looking at. It's always a good idea to do this, especially when you've got plenty of time. So I put it into the calculator. The calculator is not zooming right, so I'm just going to zoom for the data to fit. And I'm getting something along the lines of, let's do this in red, that, something on the lines of that, okay, where obviously that's y, and that is x, and I need to integrate, and I said to show my full working. So the area I'm looking at is equal to the integral of 4x plus 9 of x minus 1. Always a good idea just to put that in that form there, dx, and the bounds are between 1 and d. So full working, this is what I'm looking for. It says show your full working. So that becomes 4x, add 1 to the power is 4x squared divided by 2 is 2x squared plus 9 ln x, x power of minus 1 becomes ln x, e to 1, just get a bit more space here, substitute our values in, 2 e squared plus 9 ln e, so I should have not used square brackets, let me just use curly brackets, minus 2 lots of 1 squared plus 9 ln 1. So we get 2e squared. Now ln and e cancel out, so that's plus 9 minus 2, and ln 1 is 0, so it's just plus 0, so it's equal to 2e squared plus 7. And I wanted to see that level of working. Using the same bounds as part A, find the volume. So we're finding the volume of revolution from when your bounded area is rotated completely about the x-axis. So show the formulas that we need to use. So the volume of revolution is equal to pi times y squared dx. So we have pi times my function, which was 4x plus 9 over plus 9 over x all squared dx, and it's between 1 and d. So I'm going to use the calculator here because I think I've got enough working out there. So I've already defined the function into my calculator, so I was typing pi times the integral between 1 and e, and it's e to the power of 1, f1 of x in my case, square all of that, dx, and I get an answer which I will calculate, and which the answer is 869.303 well, let's call it units squared, and it's 6 significant figures of accuracy. Now, second function, well, notice how I've got to differentiate the function. So let me differentiate the function. So g of x is equal to the derivative of 4, so it becomes 4 minus, now 9 over x is same as 9 times x to the power of minus 1, so the minus comes forward, and it becomes 9x to the power of minus 2, so I'll keep it in like that. And the arc length formula is as follows. The arc length is calculated by doing the bounds, which are between 2 and 5, of the square root of 1 plus the derivative of the function squared dx. And I'm just going to put all of that into the calculator, so I get taking great care that I put this in exactly right into the calculator, and I get an answer of 9.78481 to 6 significant figures, and there's my 3 marks. Shown in the diagram is a traditional hourglass timer. For it to work, sand falls from one half to the other. Now, when I looked at this, I thought I don't want it to do that. I thought I saw a function. I thought I saw, when I turned it around, I thought I saw a cosine function or a sine function. I thought, so if I just sketch my function out, I thought I saw something along the lines of, now that's not the only one you can use, but I thought this might be easier to do the second part. Okay, so I'm just doing my personal take on this question, okay, and I'm going to do parts E and F together. So my function, I was going to say, I was going to model my function f of x is equal to sine x. But I have to be careful because it's only bounded between certain parts. So I'm going to define it more by bounding it. So sine x, when we have it's between minus pi by 2 x to pi by 2, or otherwise. Now I'm going to calculate the volume of revolution of that. So I'm going to take the volume of revolution, which is pi times the integral between mine. Now I only want the volume of the top bit. So if I use the volume of the top bit, because it says determine the volume of sand that must pass through, so now I'm not writing down my arguments, I'm talking to you about my arguments of why it looks like it does. So it's the formula for the volume of revolution is pi times y squared. I didn't even really go that far. Pi times y squared, so it's pi, and it's between 0 pi by 2 of pi times y squared, and that's equal to, in my case, the following. Now, I'm not saying this is the only answer you could have, but it's the answer that I've chosen to use. And I get a volume of pi squared by 4 units cubed, and it's from one, so, and it gets per minute, so the volume per minute is going to be this divided by 60. So it's units cubed per min, and that was 6 marks for everything. That's what I was talking about.